Hello, this recording is about famous classical techniques in machine learning. I'm going to cover k-nearest neighbors, support vector machines, decision trees, ensemble learning, and random forests. The reference for these techniques is your textbook, especially chapters 5, 6, and 7. Let's start with k-nearest neighbors. Here, in this technique, we find a predefined number of training samples, k, closest in distance to the new point and predict the label from them. For example, here we have known samples, red and blue, and this is the green one is the unknown sample. We can classify it or predict its label from the closest known samples to it. We can use this technique for regression or classification. In a classification problem, if we want to classify which class the green is, and let's assume that k is 3, the closest 3 neighbors are 2 red and 1 green. The majority is red, therefore we can classify the green to red. The number of samples can be a user-defined constant, k nearest neighbors, like this one. We always find the k nearest neighbors, like 3 nearest neighbors, or can vary based on the local density of points. We can specify radius-based neighbor learning, like we specify a radius like this one or a larger one like this one, and within this radius we find what are the known samples in this area, and we classify the unknown one based on the samples within this radius. Notice that if we increase the radius, we can get different results. Like if we select a small radius, then this sample is red. But if the radius is enlarged, then there are 3 blue and 2 red. We then classify this one as blue. The same thing with k. If we increase k from 3 to 5, the classification changes from red to blue. The distance can be any metric measure. Usually the Euclidean distance is used. There is a good reference for the k-nearest neighbor classification and regression on the scikit-learn website. Scikit-learn do support k-nearest neighbor classification. It has a class called k-neighbors classifier. It has the 2 important parameters are n neighbors, and the default value is 5, and weights, which has a default value uniform. Weights can be uniform. In this case, all points in each neighborhood are weighted equally. And the second option is distance, where points are weighted by the inverse of their distance. Now, this is an example how we can use this class. Import this class from the neighbors collection of scikit-learn, then make an object from this class. Here we're using the default parameters, and then you can train by using the fit function. These are the features, and these are the labels, label vector and features matrix. Scikit-learn also support nearest neighbor regression. It has a similar class, k neighbors regressor, same default values here. The label assigned to a query point is computed based on the mean of the labels of its nearest neighbors. And this is an example similar to the classification example. Import k neighbors regressor. Here we make an object of this class, but we change the default number of neighbors from 5 to 3. Then we do the fitting. This is the end of this recording.